So viscosity is defined as the property of a fluid by virtue of which opposes the motion of the fluid particle, and this property really exists in nature. Basically, fluid has two categories. One is called as liquid and one is called as gas. Both come under fluid category. In case of liquid, this property is due to cohesive forces. Cohesive force is the attraction between similar molecules, and in case it's a intermolecular momentum exchange, and both the cohesive forces and intermolecular forces, they are basically a strong function of temperature, because if you increase the temperature, the cohesive forces will going to break up and therefore the liquid will try to move easily. Whereas in the case of intermolecular momentum is defined as mass into velocity. If the temperature will increase, the kinetic energy of the gases will increase and therefore momentum will increase. So if there is more momentum, more energy to flow. So fluid will become viscous. We'll discuss this later on. And it also depends sometimes very little on the basis of pressure. But the pressure has hardly any role, but effect is less. So whenever we have a flow between a fixed plate and one plate moving, that flow is called as Coeutte flow. So remember the scientist name. Coeutte flow is a one-dimensional, incompressible, viscous flow in which the upper plate moves with a velocity equals to u and bottom plate is stationary. And the governing equation remains same. The governing equation is what? Tau is equals to mu into this time du by dy. And if the velocity profile is linear, then we can write this equation as mu into v by t. But remember, the Coeutte flow, we always assume the velocity profile is linear. That is the speciality of this. So fluid always move in the linear fashion. That is the assumption of a Coeutte flow. So in this case, this equation is applicable for you, and is always applicable for Coeutte. And once you know this, and if you know the area of this plate, can we find out force? Force equal to what? Tau multiplied by area. Area is weighted area. And if you know the velocity of this one, if you know the force of this one, then you can also calculate how much power is dissipated in friction. That equal to what? Force multiplied by velocity. क्या ये हमारा vertical distance t होगा? Is it a vertical distance t? And on any plate, are you measuring the y distance from bottom plate? Now in the case of Viscosity flow, we have a circular section. And in the circular section, you will find that the velocity will go on increasing because this wall is fixed. Actually, this wall and this wall, or is it a one wall only? It's a one wall actually. So here the center plate is moving. So is this idea and this idea is same idea? Only thing that here there is no upper plate, but there is a lower plate. Lower plate is this one. That is the wall of this one. So if you develop this surface, you will again get a plate. So this figure, that is this figure and this figure is same figure. So this one is my wall surface, this surface, and over this surface the fluid is moving. So I will show up to this level, that is up to this point. Is it a center velocity? And therefore will the center velocity will be max. And anytime are you going to measure the distance of radial distance r from center, then in that case is this value will be equal to capital R. Is it a radius of the pipe? V is the velocity of the top layer. Then if you want to apply the same law to the Viscosity flow, then we have a concept like this, that we have a fixed plate and the upper plate is moving, and anytime your distance has to measure from bottom plate, and your radial distance is always measured from axis. On axis we have center line velocity v. So is this value is same as small r, and this r is variable. If you put r equal to 0, you are on center line. If you put r equal to capital R, you are on the wall, and on the wall your velocity is 0, that is no slip condition. So I can generate one equation for r here. So can I write r is equals to y plus r? Is this distance is same as this distance? So is the distance y is equal to capital R minus small r. Radius r will not change. So if I do the partial differentiation of this one, will I get dy equals to 0 minus of dr? In that case, can we replace the Newton's law of viscosity, that is du by dy equals to, du will remain same, dy will be replaced in terms of dr. So is it equals to tau equals to minus of mu multiplied by du by dr. And at what radius you are interested, you differentiate, put that value and find out. Now this velocity gradient at r equal to 0, is it here? Is it a maximum value? Is the velocity 0? Where the velocity is 0, the shear stress is maximum. In this case, if the velocity is maximum here, if the velocity is maximum here, your shear stress distribution will go exactly opposite. So this one is shear stress distribution. If the distribution of the bottom side is maximum and is go on decreasing. So what is the shear on the top surface? Is it 0? So this is tau variation and this one is velocity variation. How it will going to vary here? So is it going to vary like this? If I am showing the upper half, is it like this? And same is true for the bottom also. So shear stress and velocity, they always act in the opposite direction. And where we have a solid wall, the shear stress is maximum. This time u is a function of radius.